Hey everybody, Mr. Bowman here. In this video we're focusing on 2.7 calculus. We've got all the merit questions from the 2019 exam. Just a reminder, these questions are all the NZQA past questions, so I can't take any credit for them. I've just kind of compiled them all in one place and given you a bit of an explanation for them. So if you're wanting more of these merit questions, check out the link in the description to this video and you'll find them all there. So let's get straight into question number 24. Question number 24, we've got Sophie. She's blowing up a balloon and it's got a volume of this area. A volume of this equation here. We've got the units, so the volume is in meters cubed, the radius is in centimeters, and we've been asked to find the radius. So we need the radius for when the rate of the change of the volume is this number here. So basically, what we're going to do is I'm going to jot down my function here. So volume is equal to 4 over 3 pi r cubed. I want to note this 25 pi, that's what V dash is equal to. So V dash is going to be equal to 25 pi. That's the change at that particular point in time. So what we need to do to match these two things up here, we're going to need to differentiate my volume formula to then get a gradient function of V dash, and then I can equate them and do some math from that. So let's get into V dash. So V dash, we have got our coefficient of 4/3. We times it by the power. Pi is a constant, so we'll leave that in there, and then we times that by r squared, my power dropping by 1. That divided by 3 and times 3 would cancel each other out, so that's going to leave me with 4 pi r squared. And I know at this point, well, that's what V dash is equal to, and I need to set that to 25 pi, so those two are going to be equal to each other. So carrying on to the next step, so 25 pi will be equal to 4 pi r squared. And now here I'm really just solving for r, because that's what the question was, right? Find the radius. So I'm going to start by dividing both sides by 4 pi. So divide by 4 pi, divide by 4 pi. So 25 pi over 4 pi is going to be equal to r squared. Here these pi's are going to cancel each other out. So that means r squared will be equal to 25 over 4. I can now square root both sides. So r is going to be equal to 25 over 4. And put that straight into your calculator. You can use the surd rules if you want to, but I didn't. That got me to 2.5 centimeters. Now to question number 25, and these graphing ones, there's always one or two of these in exam, and they're always typically the worst one done from my experience. So hopefully I can give you some tips on doing that better. So the first thing I always use is I always use my graph skills. So the question here, that graph is a positive cubic, right? So it's a positive cubic. If you differentiate a positive cubic, for example, something like x cubed, if I differentiate that, that gets me to 3x squared, right? And that 3x squared as a graph would be a positive parabola. So my positive cubic is going to become a positive parabola when I differentiate that. So that's the first thing to note. So the original function will differentiate to a positive parabola when I'm looking for my gradient function. I then need to pull out a bit more information. So the way I like to do that is I like to do the next steps here. So the turning point, so at this turning point here, we know that f dash x is equal to 0, i.e. that's going to be one of the x-intercepts. And the same thing over here, down the bottom there, f dash x is going to be equal to 0, and that's going to be another x-intercept of my parabola, or my parabola, which is the gradient function. The next thing I want to note is we can see this section here, that part of my cubic is increasing, which means it's going to have a positive gradient. From here to here, we know it's decreasing, so that's going to have a negative gradient, and here onwards, again, that's increasing, so it's going to have a positive gradient. So I've just changed pen colors to this lighter green so you can see what I'm doing here. So I guess the first thing to note is let's jot down the x-intercepts first. So we said this is going to be x-intercept, so going down to the x-axis, my parabola is going to go through that point there, and same thing here, let's go up there, and then my parabola is going to go through there. So those are going to be my two x-intercepts of my parabola. So my parabola is going to have a positive gradient. Well, it's a positive parabola, right? So we're expecting it to kind of be U-shaped, and it's going to be U-shaped going through my two x-intercepts. So I'm going to draw my parabola, so it's going to go, I'll draw a better one than that. So it's going to go down there, and then it's going to start going up. So that's the parabola I'm going to draw. Let's just check makes sense. So remember this first section here needs to be positive, right? Because it's going up. And this section here is in the positive section of the y-axis. Great, this stuff here, that all needed to be negative, and that's below the x-axis, so it's got a negative gradient. And then finally, that's all above the x-axis again, so it's got a positive gradient. So it now matches this positive and negative gradient stuff that I identified. So that light green parabola, that's the type of thing that they'll be looking for this particular question. So we're now into question number 26, and we got another graphy one, but it's actually not that graphy. So basically, the key facts of this question is, so we're trying to sketch the original function. So we've got the gradient function, we're trying to sketch the original function, and the other bit of information they've told us is the original function goes through 0, 0. So that means for the original function, we know when x is equal to 0, y will also be equal to 0. So the way I did this one here is, what I did is I just found the equation of this line using y equals mx plus c. So jotting that down there, y equals mx plus c. Once I did that, I then found all those. I saw that my y-intercept was up here, and that was positive 6, right? So that told me that c was going to be equal to positive 6. I then found the gradient. I did my kind of rise over run. So it rose -3, run 1. So -3 over 1 is just -3. So that told me my gradient was going to be -3. So my function, or my gradient function, I should say, so y dash, was equal to -3x plus 6. Now that I've got that, I'm going to integrate this to get back to the y function. So y is going to be equal to -3 over, remember, power plus 1. We've got invisible power of 1 up there, so it'll be 1 plus 1 as division. So we've got x, 1 plus 1, then that's going to be plus 6x plus c, and simplifying that, that's going to be -3 over 2 x squared plus 6x plus c. So we've got that there. We now need to figure out that constant, and that's where this kind of origin y equals 0, x equals 0 stuff comes into play. So at this point here, we can figure out c. We knew that y is equal to 0, so 0 will be equal to -3 over 2 times by x is 0, so 0 squared, plus 6 times 0 plus c, and simply put, all of that is going to cancel. So c is equal to 0, which means y is equal to, putting it there, so it's going to be -3 over 2x plus 6x. So now that I've got that, I've got the actual function. So what I'm going to do here is I'm just going to find out what the two x-intercepts are, what the vertex is, and then I'm just going to draw the graph. You can also pop this into your graphics calculator, the graphing mode, and you can pull out those information. That might be a bit easier as well, but I'll just do it manually here. So working up the top of the page, I've got y is equal to, I'm just going to factorize my expression. Oh, I just realized I've got the squared there. I'm just going to factorize that. So that's going to be x bracket -3 over 2x plus 6. And from that, I can get my two x-intercepts, right? So my first answer will be 0, and then my second answer will be, that's going to be a bit messy to calculate. Let's do that fully. So that second bracket, let's set it to 0. So -3 over 2x plus 6. When is that equal to 0? So we've got -3 over 2x is equal to -6. Do a times by 2 to both sides. Get rid of that divide by 2, times it both by 2. So -3x equals to -12, which means x is equal to 4. So those are my two x-intercepts. From that, I know about my vertex, right? My vertex has to be in the middle of those two. So my vertex will be when x is equal to 2. And I can find the y value of the vertex. I can find the exact point by substituting that back into the function here. When I did that, it came to 6. So I've now got all the information I need, right? I've got my two x-intercepts, so x-intercept, x-intercept, and then I've got my vertex information there. Let's go ahead and pop that into my graph. So 0, so in the origin there, that's going to be one of my x-intercepts, and also positive 6. So we've got 1, 2, 3, 4, 5, 6. So that there will be my second x-intercept. I can now plot my my vertex. Oh gosh, I've put it at 6 actually. That's meant to be positive 4, isn't it? So it's going to be over there. So -2, so positive 2, somewhere in that area is going to be my vertex. It's going to be up 6 though. So we've got 1, 2, 1, 2, 1, 2. So up here is my vertex. And then now that I've done that, I can just connect those dots to make my parabola. So I'll do that down there. Not the best drawn parabola in the world, but it'll do for an exam because they don't expect perfect ones. And there you go. So that's my parabola. Now moving on to question number 27, second to last merit question from this exam. So we've got a remote control car. They're moving back and forth. The displacement is given to that equation. And then what it's saying is that the car is moving back and forth along a straight track. So if you imagine a track, you're moving back and forth, right? So that kind of looks like a parabola, right? It would go forward and then it would head back. And obviously that axis there is as time goes on. So let's write down our formula. So we've got displacement in terms of time, so 6t minus t squared. So we're looking for when does the car change direction. So it will change direction when the velocity is 0, right? So when velocity is equal to 0, because that means it's going forward, it stops, and then it turns back in the other direction. So what we're going to need to do is we're going to need to differentiate our displacement here to get a velocity formula. So velocity will be equal to 6 minus 2t. From that, we know that the velocity is 0, so I'm going to sub in 0 to solve for t. So 0 is going to be equal to 6 minus 2t. 2t is going to be equal to 6. T is equal to 3. So what that tells us, I'm going to put it in a bit of sentence. It tells us that car changes direction after 3 seconds. So this tells us that the car changes directions after 3 seconds. So I've changed to the red pen. Let's do question 28 carrying on from this because they do continue from each other. And then the question says is how fast is the car moving when it gets back to P for the second time? So I drew a parabola before. So basically what happens is as time goes on, so remember that's time, it's starting at point P, it travels away. So it's traveled for 3 seconds and eventually it returns back. So that there is also point P. So basically if you think of the parabola, these P's here, those are just the x-intercepts of the parabola. And we can find how fast it's traveling by figuring out the time and then using the velocity formula. So we're going to need to do that. So let's find the x-intercepts of my displacement formula, right? So displacement is going to be 6t minus t squared. We're going to set that to 0 because y is equal to 0 at the x-intercepts. So factorizing here, so t, so that's going to be 6 minus t. So we're going to have two answers, right? t1 is going to be equal to 0, which makes sense. That's the very original start point. And then t2 will be equal to 6 seconds. And that makes sense because at the vertex it's 3, so it's 3 seconds to get there, 3 seconds to get back. So that means it's back at the original point at the 6 second mark. So we now need to find the velocity at 6 seconds though. So we need to find the velocity at that 6 second mark. So remember velocity from our previous differentiation, is going to be 6 minus 2t. We've already figured out t, so it's going to be 6 minus 2 times 12. So that's going to be negative 6. So negative 6 meters per second. And that wraps up all of the merit questions for this 2019 exam. If you're looking for more merit questions like this, check out the link in the description to this. I think I've got all of the merit questions from like 2015 to present all in one place. So hopefully you find it a really useful resource.